What we're going to be talking about today is solubility. This is what you saw in the lab yesterday, as well as in the second part of your sugar lab from last week. Solubility is defined as the maximum amount of solute that can be dissolved in a given amount of solvent. So if you remember the sugar lab from last week, we used a very small amount of water, and we continued to put sugar in until no more sugar would dissolve. From that information, you calculated the solubility. How much sugar could that amount of water hold? There are three factors that can affect or change solubility. Remember, solubility tells you how much of a given solute will dissolve in a given amount of solvent. There are three things that can change that amount. Be careful that you don't confuse the factors affecting solubility with the factors that affect the rate of solvation that we talked about last week. The first factor that can affect solubility, or how much of something will dissolve, is likes dissolve likes. We talked about this earlier this week. Compounds that have things in common will mix with each other. Compounds that do not have things in common will not mix with each other. So what are those things? What do they have to have in common or not? As we talked about earlier this week with our water and alcohol versus water and oil examples, polar things dissolve other polar things, and nonpolar things will dissolve other nonpolar things. But if you have something that is polar and you try to mix it with something that is nonpolar, those two things will not mix very well. Unless, as we mentioned earlier this week, you have one of those special substances that will connect both with the nonpolar things and with the polar things and allow them to mix together, like soap. Soap is a very special compound. One end of a soap molecule will hook onto a water molecule. The other end will hook onto the oils on your skin. So when the water side goes down the drain, the oil side has to go with it. And that's how soap cleans your skin. The second factor that can affect solubility, or how much of something will dissolve, is the temperature. And we're going to look at what happens when the temperature increases or goes up. As the temperature goes up, the solubility of solids in liquids increases. Some of you mentioned this last week when we did our sugar lab, asking if the sugar would dissolve better if we made the water warm. The solubility of solids in liquids goes up when the temperature goes up, so you can dissolve more of it at a higher temperature. On the other hand, the solubility of gases in liquids decreases with increasing temperature. If you think about this, this should make sense. If you make something warmer, you're going to have more molecules with the energy to change from the liquid phase to the gas phase. More molecules, in other words, will want to be a gas, and less will want to be a liquid, or less would want to get dissolved. So the solubility of gases goes down as the temperature goes up. This is something that pop companies have to think about when they are going to make their product. If they try to dissolve the carbon dioxide in the pop at a high temperature, maybe it's hot in the factory, the carbon dioxide won't dissolve very well. So, to help fix that, they lower the temperature. So more of the carbon dioxide will dissolve into the pop, and then your pop will be more fizzy. The third thing that can affect solubility is pressure. But we really only consider pressure when we are considering a solution that's made with a gas and a liquid. Gases are more soluble in liquids that are under higher pressure. This should make sense too. Imagine that there's pressure on the top of the liquid pushing the gas down into it. Gases are more soluble in liquids under high pressure. This idea is known as Henry's law, and if you have a really good memory, you might remember that it was one of the questions at Science Fest that you hadn't learned yet, even though we had just finished gas laws. Henry's law actually has a lot to do with scuba diving, and why scuba divers have to be so careful when they come back up to the surface. If any of you have ever been scuba diving, you know that if you come back up to the surface too fast, you can get something called the bends. And the bends are really painful. They're called the bends because they're so painful that when you get them, people tend to crouch over and bend over. They're caused by a different amount of gases being dissolved in your blood than what are normally supposed to be there. So as you go down into the ocean and your body is under higher pressure, the gases are more soluble in your blood. So more of those gases dissolve in your blood. And then when you come back to the surface, those gases are less soluble. And so they come out of solution, and you can get little bubbles of gas in your blood. And that's very, very painful and can be kind of serious if you do it really quickly. So you have to be very careful when you go scuba diving that you don't come back up to the surface too fast. Now that we've looked at the three things that can affect solubility or how much dissolves, we're going to take a closer look at solid in liquid solutions. This is what we deal with most often. And what we're going to look at are the stages that these solutions go through as you continue to increase the amount of solid that's dissolved. There are three stages that a solution goes through as you continue to dissolve the amount of solid in a certain amount of liquid. The first stage is called unsaturated. This is where you have just begun to dissolve small amounts of solid in the liquid. At this point, right at the beginning of the dissolving process, the solution contains less than the maximum amount of solute. This means that all the solute you're currently putting in dissolves pretty quickly, and there is still room for more. So if you think to last week's lab with the sugar, this would be where you just started adding sugar to your water, and there was plenty of room for more, and the sugar that you started with dissolved pretty quickly. Stage 2 of the solution is called saturated. After you had dissolved sugar for a while in your lab last week, eventually you should have gotten to the point where you began to see crystals of sugar collecting on the bottom instead of dissolving. This is where your solution became saturated. At this point, the maximum amount of solute is dissolved. So this is the point where you had dissolved all of the sugar that was possible. If you continued at this point to add more solute, if you continued at this point in your lab to add more sugar, whatever you continue to add will not dissolve at that temperature. Instead, it just collects on the bottom. But as we mentioned earlier, solubility, and thus the point where you reach saturation, depends on temperature. So if you were to take that saturated solution and make it warmer, you would change your amount that could be dissolved, so you would change your saturation point, and you could dissolve more in it. you know you've reached the saturation point when the rate of the solute dissolving is equal to the rate of already dissolved solute recrystallizing. Crystallizing means turning back into a solid. So when the rate of dissolving equals the rate of crystallizing, then you've reached the saturation point. Stages 1 and 2 of dissolving solutes are the most common and the ones that we deal with most often. So before we move on to stage 3, we'll stop and draw a picture, just to be sure that we all understand stage 1 and stage 2. In this picture, we will have up arrows that represent molecules that are dissolving, and we will have down arrows that represent molecules that are crystallizing. We're going back into a solid. Our picture will have 3 stages. So we will have 3 cups of water. And we better put some water in there. Next, we'll draw in pictures what you did in your sugar lab last week. One of the parts of the lab, you started with a sugar cube and you watched it dissolve. And at first, there would have been a lot of sugar molecules dissolving. So we'll represent that with 3 up arrows. This would have been right after you put the sugar cube in. So the sugar is dissolving in water. After a little time went by, you would have noticed that the sugar cube was a little smaller. And the dissolving process would get a little bit slower. You'd still have quite a few molecules dissolving, but even though you can't see it, now we have some molecules recrystallizing. So some of the molecules dissolve, and some of the molecules crystallize. Now at this point, when you did your lab, you just waited until the entire sugar cube was gone. But if we had used less water, we might have reached a point where there was a little sugar left in the bottom that just would not dissolve. And at that point, we would have had the rate of dissolving equal to the rate of crystallization. For every molecule that dissolves, 1 crystallizes. So dissolving is equal to crystallizing at this point. And we've used this word before, but this is what we call equilibrium. We have opposite processes at equal rates. And, as you have hopefully guessed, this third picture is where your solution is saturated. This third picture is saturated. The first one and the second one are both unsaturated. Last thing for today. Let's not forget we haven't done stage 3. Stage 3 goes beyond the 3 pictures that we just drew to where you can get a solution supersaturated. And you might be able to guess what that means. A supersaturated solution is one where you have managed to get more solute dissolved than the solution would normally hold at that temperature. So you have been careful enough and done the process slowly enough that you can get the solution to hold more solute than it should. Sometimes you can make these by carefully cooling a hot saturated solution. If you raise the temperature and dissolve more solute, get to that saturation point, and then you cool the solution back down, some of that solute should recrystallize. But if you cool it slowly enough, sometimes you can get the solution to stay dissolved, to stay in solution. And so that would be called supersaturated, where you force the liquid to hold more solute than it normally would. But supersaturated solutions are very unstable because you have to cool them so slowly and so carefully. So they would really like to crystallize. The solute would really prefer to recrystallize. So sometimes even if you just bump it or stir it, that will be enough to cause it to crystallize, and then you won't have a supersaturated solution anymore. As you do your homework for tonight, look at the worksheet. You will see that there is a graph with several different lines on it. Each of those lines represents a solubility curve for that substance. So every point on that line is a saturation point. And then you would read the amount of solute that it holds at that given temperature. Every point on each of those curves is a saturation point. And look at the way the curves either slope up or slope down, and that will help you answer a couple of the questions. Good luck!